Hi everyone, and welcome to today's lesson on crude oil and alkanes. So have a look at the learning objectives for what we're going to be covering in this lesson. You're going to be able to define crude oil and alkanes. You're going to be able to describe the structure of alkanes and name the first 5 alkanes and calculate the molecular formula. And we're going to master GCSE paper questions on crude oil and alkanes. So if you are treating this as a regular lesson, I would suggest that you have your workbook with you or some paper where you're keeping all of your revision notes together. If you're not and you just have access to your phone, maybe you're watching this on an iPad or something, that's absolutely fine as well. You can still take part in the activities. So today's title is Crude Oil and Alkanes. And there are key words at the side: saturated, unsaturated, bond, fuel, and alkanes. There is a question to get you thinking, okay, a starter question. It says, what is this picture showing? So what is this picture showing? It's quite a big question. It's very open-ended. Now, some of you will be able to maybe name that molecule straight away. Some might be able to say, well, I can see a couple of different elements, but I'm not really sure why they're displayed in that way. And some of you might see something completely different. Some of you might be able to see that the line represents a bond, okay, a specific bond, actually, a covalent bond. So again, there's lots of different things that actually this, even though it looks quite simple, there's lots of different things that it's showing. And you'll be able to really answer this quite specifically by the end of the lesson. So crude oil and hydrocarbons. Crude oil is so valuable, it is known as black gold, okay? It's also the cause of many political issues, but what is it? What actually is crude oil? Okay, well, it comes from a set of finite resources that are actually found in rocks, okay? And it's formed over millions of years ago from the remains of tiny insects and plants. It's made of a mixture of different carbon, it says a mixture of many different carbon mixtures called hydrocarbons. Okay, so it's a mixture of different hydrocarbons. If you have a look at this, you might be thinking, oh, I think I've seen something like that, but I don't know what it is. It's actually an oil rig. Okay, so something like this kind of complex machine is built out in the oceans. Okay, and what it does is it digs down and digs down, very, very deep through the initial rock that you hit at the bottom of the ocean for oil, for crude oil, which is quite a thick, black, kind of gloopy substance. If you've ever seen a road being laid with tarmac, thick black tarmac, it's a similar consistency. So again, it looks like this. This is crude oil, okay? And obviously there are lots of environmental implications when it comes to crude oil, and you might get some questions on that in your GCSE. This lesson won't be going into those. It's just kind of going into what is crude oil. So this is just a visual representation of what's going on. So it's underneath, okay, underneath a very thick bed of rock, usually out in the oceans, but it can actually be on land as well. So usually if you dig down through the layers of the rock, you sometimes find a gas reservoir, okay, or a natural gas reservoir, which we also use as a fossil fuel as well. And here you have your oil reservoir. So this is what we would dig up and use as crude oil. Now, what was I talking about in terms of there was a mixture of hydrocarbons? Well, this is actually a visual representation of a mixture of hydrocarbons. So on this slide, you can see a mixture of lots of different lengths of hydrocarbons. Okay, now these are separate molecules. So you've got long ones, short ones, and they're all different lengths, and they all contain carbon and hydrogen. So they only contain those 2 elements. Okay, so these are hydrocarbons. The different hydrocarbons found in crude oil have different numbers of hydrogen and carbon atoms. We say they have different chain lengths. Okay, so these are some of the, or 2 of the really, really key points to put in your notes if you're taking notes. Crude oil is a mixture of different hydrocarbons. Okay, so that's just 1 mark, and it could be in your GCSE. So it could say define crude oil. Your answer would be a mixture of different hydrocarbons. Hydrocarbons are compounds made from hydrogen and carbon only. Now that might seem quite obvious from the word hydrocarbon, but you'd be surprised. All right, so if, for example, one of these atoms, if you look at my mouse, was actually chlorine or bromine, or it could be anything really, it could be any different element, it would not be a hydrocarbon. So it's really important that you understand that hydrocarbons just have hydrogen and carbon, okay? So there is a little summary if you kind of, again, like to make sure that you have everything in your notes. All right, so there's 3 questions that say, where does crude oil come from? Why is it useful? Okay, and what do we find in crude oil? So I would suggest, actually, if you're looking for a bigger answer to this bottom question, that you look at the lesson on fractional distillation, because that lesson is all about how we separate crude oil into useful fractions. So crude oil itself, as a thick, black, goopy substance, it doesn't have actually very many uses as itself. What we can do as scientists is we can separate them into different length chains of hydrocarbons, all right, and they can be used for different things. So again, the fractional distillation lesson will go into that in a little bit more detail. Let's have a think about this again. So what can you see that is a similarity or a difference between these 2 hydrocarbons? So this is the one that you saw in the starter, and this is something new. If you go into a lesson on alkenes, you'll also see these 2 as a starter question, but hopefully you can get an idea of the difference between the 2. So both of them are hydrocarbons. Okay, so that might be a similarity already. Both of them are hydrocarbons, which means that they contain carbon and hydrogen only. Maybe you're counting the number of carbon atoms. Maybe you're thinking, right, how many lines there are. Remember, the lines represent bonds. And then maybe you're also looking at these as differences and going, well, okay, this one has 2 lines in the middle of the carbons and this one has 1. So this one has a double bond. We say this is a single. Also, maybe you've counted the number of hydrogens and you spotted a difference there. So really, really well done. So both contain the same element, carbon and hydrogen. There are different bonds between the carbon atoms. That is the main similarity and main difference. And this is what I mean by bonds between the carbon atoms, single and double. If you want more explanation on the bonds, these are actually covalent bonds, and we use lines to represent covalent bonds. That can be found in the bonding topic. Let's get back to alkanes. Okay, so this was the alkane. Well done if you spotted that in the last question. It is a member of the hydrocarbon family. All right, because hydrocarbons can either be alkanes or alkenes. It's a member of the hydrocarbon family. They are used as fuels, okay, like petrol, diesel, etc. They contain carbon-carbon single covalent bonds. That's just what we mentioned before. So by carbon-carbon, it means in between 2 carbons. Okay, so carbon-carbon single covalent bond. And they are saturated. Please use that key word when it comes to GCSE questions, because examiners love it. They are saturated, which means that all the potential carbon-hydrogen bonds are complete. Okay, so I can't fit on any more hydrogen onto this alkane. I physically can't do it, okay, because a carbon atom can only have 4 lines coming off of it. Again, if you're not sure why, it might be an idea to go over bonding again. Each carbon or carbon atoms, a carbon atom has 4 electrons in its outer shell because it's in group 4. Okay, so it can only form 4 bonds. Covalent-wise, covalent bonding-wise, it can share its electrons with 4 different things. Okay, and that's what's happening here. So each carbon has got 4 lines coming off of it. I cannot add another line. There is not another electron that can form a bond. So we say that this is completely saturated. Okay. Right, so all alkanes follow this rule, CnH2n plus 2. It looks really complicated, I promise it's not. This is a general formula, so we can use this to calculate molecular formula. So it's general. This basically applies to every single alkane there is. Let's take this one as an example. Now, this one is called methane. We're going to talk about names in a minute, okay? But this is called methane. You might notice that it has 1 carbon atom, okay? And you can count in terms of the hydrogen atoms, or you can use this general formula. N means number of carbon atoms. So if N is 1, H2N plus 2, remember this N is now 1, means 2 times 1, which is 2, plus 2. Okay, so we've got 2 plus 2. So if C equals 1, then H must equal 4. Okay, and is that true? Well, yes, it is, because we can use that in terms of methane. And it seems a bit complicated, but let's go through it just to make sure that you understand. All right. So the number of carbon atoms is 1, because there's 1 of them. How many hydrogens are there? 1, 2, 3, 4. Okay. So we say that methane is C1H4. Now you'll notice that that 1 has disappeared, because in chemistry, we don't often put a 1. Okay. It's implied. For example, if I was to say to you CO2, yeah, carbon dioxide. How many carbon atoms are in CO2? Hopefully, you'll be thinking 1. The formula isn't C1O2. We don't say that, okay, because in chemistry, again, we don't say when there's a 1. So that's why the formula for this methane molecule is CH4. Let's try one more, okay? Let's try one more. Let's try ethane. Again, don't worry if you don't know what it's called yet. We're going to cover that in a second, but this molecule is called ethane. All right, now let's try counting the number of carbon atoms and then working out how many hydrogen atoms there are, either by counting or by using this general formula. If the number of carbon atoms is 2, this is going to be 2 times 2 plus 2. So 2 times 2 plus 2, okay? And then think about how many hydrogen atoms that is. Again, you can always check by counting down here. The number of hydrogen atoms is 6. Let's put that general formula into our molecular formula then. Okay, so we'll count the number of carbons, count the number of hydrogens, which means C2H6. This is the molecular formula that we have calculated from the general formula. Right, now what has this got to do with alkanes? Monkeys eat peanut butter positively. Okay, it's something that I want you to memorize, because it's going to help you when it comes to naming hydrocarbons. All right, methane, ethane, propane, butane, pentane. They are the first 5 alkanes, and you just need to learn them. Meth, eth, prop, but, pent. They're the start of the word. And if you think of a 5-sided shape, yeah, like a pentagon, pent obviously means 5. So you can bet that the pentane is going to contain 5 carbons. It goes by the number of carbons each molecule has. Okay. When you do alkenes as well, it links to alkenes. So for example, instead of ethane, you put ethene, and that still has 2 carbons, but you can come to that at another lesson. Right, now with all of that information, I think it's a good idea to kind of complete this in your notes. Okay, so what I'd like you to do, I will go through the answers in a minute, but what I'd like you to do, starting with methane, name those alkanes, give their molecular formula, give their structural formula, so that's kind of showing all of the lines, okay, coming out of the carbons. And if you can, if you're quite good at drawing, you can give a ball and stick model, because sometimes the ball and stick model, they give actually those in the GCSE, so you need to be able to apply it. Okay, so really well done if you're kind of, if you're quite good at drawing, and you can give a ball and stick model as well. Pause the video and have a go at that, because we're going to go through the answers. Okay, I hope you pause the video, because I'm going to go through the answers. Please make sure that if you're marking this and you're writing this down in notes, you grab a different colour pen and you can self-assess. So ethane, C2H6, well done if you've got these correct. The reason why these are larger, okay, is because actually carbon is much larger than hydrogen. So propane, C3H8, well done if you got that correct. Butane, C4H10, and pentane is C5H11. So if you need to pause this video, I think it's a great idea to make sure that all of these are correct. And if you haven't got them correct, it's completely fine. Make sure you make your corrections, okay? Let's have a go at maybe 3 small past paper questions, just to make sure that we can apply it to kind of a GCSE past paper question format. So crude oil is a mixture of hydrocarbons. Most of these hydrocarbons are alkanes. The general formula is CnH2n plus 2. Complete the structural formula for an alkane that has 6 carbon atoms in its molecules. Try not to look back at your notes, because I know you've just drawn this, Try not to look back, because the more you practice it without looking at your notes, the easier it will become to memorise. So pause this video and have a go before we go through the answer. Okay, so did you get it? Have a look at the answer on the screen. Okay, so you've got 6 carbons, and again, make sure you've drawn these little lines to show the bonding that's taking place between the carbon and the hydrogen atoms. Well done. Let's have a go at another one. So it says the mass of a carbon atom is 12, the mass of a hydrogen atom is 1. Okay, so the molecule with 1 carbon atom has 4 hydrogen atoms. Its formula is CH4. Write down the formula for a molecule with 2 carbon atoms, and of a molecule for the same family with 5 carbon atoms. Again, come on, you can do this. Make sure you pause the video and have a go. I'm going to go through the answer shortly. Okay, so grab a different colour pen if you're marking it as we go. Well done, 1 mark for each. It says figures must be subscripted. So actually these numbers must be small. It's so important. And you know, if you're stuck when it comes to formula, there'll be another video on that. But these numbers are small, they must be, okay? You can't have them big because that doesn't make sense. That's not really a rule when it comes to writing formula. So C2H6, so well done if you put that. That looks like an 8, doesn't it? But it's a 6. And C5H12. Well done, mark for each. Last one, this one's nice. Crude oil is a mixture of hydrocarbons. Hydrocarbons can be used as fuels. 1 alkane hydrocarbon contains 34 hydrogen atoms. What is the formula for this hydrocarbon? So have a think back to the general formula. Okay, it's given you the number of hydrogen atoms, and you have to think or work out the number of carbon atoms from that general formula. Remember, CnH2n+2. So you've got to kind of work backwards. Pause the video and have a go. Okay, so let's have a look at the answer. C16H36, basically 34. Well done if you got that. Okay, if you had to kind of draw it out, you'd have been there a while. So you probably need to have used the general formula for that. Really, really well done. I hope you understood that. Okay, feel free to go back through the video again. If I've gone a bit too fast, you can always pause it and write down any notes and kind of work through things again until you get them correct. Okay, thank you very much.